Okay, this is the second part of Ohm's law. Going to be very short, just a couple of minutes. I just accidentally, my screen went off and I accidentally turned off the video, and you can't restart it when you're doing these videos. So what we had said was that if you have V equals IR, that's Ohm's law. One of the interesting things that I was trying to say right at the end is the current depends entirely on voltage and resistance. At your home, the power that comes into your house is usually 120 volts. There are wires running through the wall. If for some reason that wire were to lose resistance, maybe the wire ended up touching something else. By the way, I should point out, if the resistance went to infinity, for instance, if I have a wire and that wire snaps, if this goes to infinity, doesn't matter what the resistance is, the current drops to zero. I know that's not mathematically correct, but you don't have any current flowing. But if for some reason the resistance, which is normally like 6 ohms, were to drop, somehow maybe we had somebody wires it up, and here's your voltage here, and here's your wire that comes through here to your circuit. And somehow this wire will have a resistor in it. By the way, there's virtually no resistance in the wire. They'll have what's called a resistor, and this is the symbol for it. If somehow somebody accidentally bypasses that, so that you end up, let me do something really dramatic, where we have 0.001 ohm, all of a sudden you would have 120,000 amps that would be flowing. You say, well, what difference does it make? 120,000 amps flowing would just immediately fry that wire, burn up that wire. And so in your house, you have something called a circuit breaker. In old houses, it's called a fuse box. And basically what it is between here and your outlet, they're going to put a little device that if the current goes above, let's say this is a 20 amp wire, if the current goes above 20 amps, then there's a little piece of wire in here that burns out. And when it burns out, it shuts the electricity off. That's called a fuse. And almost anything that's sensitive electronics will have a fuse, will be fuse protected. And in your home, you have what's called circuit breaker, where instead of a wire burning out, it snaps over. It turns itself off. Basically, it's a switch that flips over. You can reset it. If you still have the same problem, it'll do the same thing over again. So that's that. We are going to do out of the book problems 6 through 11. And I do have to warn you, 6 through 11 all. And I do have the answers for the evens. 0.6 is 0.36 amps. Number 8 is 15,000 ohms. And number 10, A is 0.6 amps. And B is 208 ohms. There is a problem, I believe, where they'll ask about, they'll give you power and say current. And from power and current, P equals VI, you can figure out what, if I give you 2 of these, you figure out the other one, then knowing these, you can figure out the one here. So fairly simple math. Math on electricity is not very difficult. So with that, I'm going to stop, and this is the last video for the week of March 18th through 27th. We'll leave it at those 7 assignments, so you don't have to keep looking at your weekly instructions. I won't add anything else. If I do, I will send out an email. So, all right, God bless you, and keep safe, keep healthy, and let's hope we see each other after Easter. All right, we'll see you.